First part of 1.6. This is called, I think it's called like solving other types of equations. We're going to solve by factoring today. Tomorrow we're going to solve by we're solving rationals. We're going to be getting square roots. I'm sorry. We're going to be getting common denominators, solving equations that way. And we're also going to be solving using square roots. So today all I want to focus on is factoring. Guys, when you're factoring, number one, the first thing you look for is what when you're factoring a problem? Greatest common factor. Let's first make sure everything is on the same side. So I'm going to move this 9x cubed over here. So I have x to the fifth minus 9x cubed equals 0. When you're factoring, you want everything to equal 0. So now I look and I say, okay, I have x to the fifth and x to the third. What can I take out of x to the fifth and x to the third?
X to the third.
I can take it out an x to the third. So when I do that, x to the third divided by x to the third. I have the same bases that I'm dividing, so I subtract 5 minus 3. I'm left with x squared, and then my x to the thirds cancel out, minus 9 equals 0. I always have to check, can I factor this more? So I have my x to the third. I can't do anything else. What can I do with x squared minus 9? What is that?
What is it, like perfect squares?
It is. It's the difference of perfect squares. There's a minus sign in the middle. And both x squared and 9 are perfect squared. So I have an x in the front of each parenthesis, a plus 3, and a minus 3. Now, it says to solve the equation. That means you want x equals. So I have to take each piece and I set it equal to 0. So x cubed equals 0, x plus 3 equals 0, and x minus 3 equals 0. So how do I get x cubed to be just plain old x?
Square root.
I'm going to take the cube root. Yep, I know what you meant. Take the cube root of one side, take the cube root of the other, so I get x equals 0. I'm going to subtract 3 from both sides here, so I get x equals negative 3. And I'm going to add 3 to both sides here, and I get x equals positive 3. So I have solutions at x equals negative 3, positive 3, and 0. If you were to see this on a graph, that means it would cross the x-axis at 0, negative 3, and positive 3. You guys okay with that? We all right? Okay. Next one. First thing I look for when I'm factoring, is everything set equal to 0? Yes. Next thing I look for, is there a GCF? Is there a letter that I can take out of all three of these?
Yeah.
What can I take out?
X.
An X? Good. Is there a number that they all have in common?
2.
Yeah, I could take out a 2. And remember, guys, if we lead with a negative, what should we take out? What kind of a 2 should I? Yes, a negative 2. So I'm going to take out a negative 2. So if I divide this by negative 2, x, negative 2x, negative 2x. I'm left with negative 6 divided by negative 2 is 3. And x cubed and x gives me x squared. Negative 20 divided by negative 2 gives me positive 10x. And then 16 divided by negative 2 is negative 8 equals 0. You guys with me? All right, now we're going to factor. Guys, all this factoring stuff is never going away. We're doing the same thing right now in my pre-calc class. I'm factoring where A is not 1. So I have to say A times C is negative, right, 24. What are the factors of 24 that when I multiply I get a negative 24, but when I add them together I get 10? I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. What could give me a negative 24 when I multiply?
2 and 12.
Yes, 2 and 12. Good. A lot of you would make the mistake of saying 4 and 6 because 4 plus 6 is 10. But there's no combination of plus and minus that I could do that would give me a negative 24 but a positive 10. So good. I'm going to say x plus 12 and x minus 2. Because think about it. 12 times negative 2 is negative 24. And then 12 minus 2 is 10. So good job. Now, before I can simplify and say I'm done, my a term, remember, was not 1. So I put the 3 underneath both factors. So I'm still working. I have negative 2x. Does 12 divide by 3 evenly?
Yeah.
Yeah. So this becomes x plus 4. Does 2 divide by 3 evenly?
No.
No. So this 3 comes out in front. So I have 3x minus 2 equals 0. Now I cannot factor those anymore. Everything is broken down as much as possible. So what do I do with each of these pieces in order to get what my x values are? I set them all equal to what?
0.
Yep. Negative 2x equals 0. X plus 4 equals 0. And 3x minus 2 equals 0. So divide both sides here by negative 2. I get x equals 0. Minus 4 from both sides. I get x equals negative 4. Add 2 to both sides. 3x equals 2. Divide both sides by 3. And x equals 2/3. So what does this tell me? What's going to happen at these 3 points on the x-axis when I draw my graph? What does this mean? My x values. These are my x-intercepts. When you guys solve for these, when you factor, you're finding where the graph crosses or touches the x-axis. That's important to remember as we get going along and stuff. All right, let's look at the next two. We're going to do the next two, and then I'm going to let you guys start your homework. First thing I look and say, okay, is everything on the same side and it's set equal to 0? Yes, it is, right? Now, the second thing I do is there a GCF? Is there a letter or a number that goes into all 4 of these terms?
No.
No. So if I have 4 terms, let's try and group it. Sometimes grouping doesn't work, and we're going to get to some problems that don't. But right now, grouping is going to work for us. So what can I take out of that first parentheses, x cubed and x squared? What can I take out?
X squared.
I can take out an x squared. Good. So when I divide x squared, I'm left with x plus 3, correct? Now in the second parenthesis, what can I take out of negative 4x and a negative 12? Remember, if it leads with a negative, you want to take the negative out. So what can I take out?
Negative 4.
Perfect. Negative 4. When I divide by negative 4, I'm left with x. Negative divided by negative is a positive 3. What is my new GCF between this term and this term? What do they both have in common?
X plus 3.
X plus 3. You take out the GCF just like you would any other time, and you write it one time out in front. Now it's gone. And the leftovers get their own parentheses. So I'm left with x squared minus 4 equals 0. Am I done?
No.
What else can I do?
Factor out the x squared minus 4.
I can. That's the difference of perfect squares. If it's a perfect square on either end and it's a minus sign in the middle, it's x plus 2, x minus 2. Now I take these 3 parentheses, I set them equal to 0, and I find my x-intercepts. I find my roots. I find my solutions. However you want to say it. All those things mean the same thing. So I'm going to subtract 3 from both sides, get x equals negative 3. I'm going to subtract 2 from both sides and get x equals negative 2. And then I'm going to add 2 to both sides and get x equals positive 2. Questions? We okay? Everybody all right? All right, last one, and then I'm gonna let you get started. Look here. First thing, is everything on the same side and set equal to 0? Yes or no? Are all of my terms on one side of the equal sign and zeros on the other side?
Yes.
Okay. Is there a GCF? Can I take a common number or letter out of all 4 terms?
No.
Then we need to try and group it. What can I take out of 4x cubed and 3x squared?
X squared.
Okay, if I take out that x squared, I'm left with 4x minus 3. What can I take out of negative 16 and a positive 12? What can I take out?
-4.
Negative 4, good. So if I divide by negative 4, I get 4x minus 3. What do you guys notice the new GCF is? What do they both have in common?
4x minus 3.
They both have a 4x minus 3. I take that out and I write it one time in the front, and then what happens to my leftovers?
You put that in parentheses,
Yep,
right?
they get their own parenthesis. Good. And now I check and I say, wait a second, can I factor this anymore? I can't do anything else with 4x minus 3. That's as small as it's going to go. But can I do anything with x squared minus 4?
Yes.
Yep, difference of perfect squares. So x plus 2, x minus 2. And now in order to get my zeros, my solutions, my roots, my factors, you're going to set each piece equal to 0. So I'm going to add 3 to both sides here. I get 4x equals 3. Divide both sides by 4, and I get x equals 3/4. I'm going to subtract 2 from both sides, and I get x equals negative 2. I'm going to add 2 to both sides and get x equals positive 2. How do you guys feel? This isn't anything new. You've all seen this kinds of factoring and stuff. It's just a matter of being able to work this out. So this is the first part of 1.6. So you guys now should be able to take these examples and to look back and do numbers 1 through 10 on your web assign.